All right, about to get started here. Oh, yeah. Okay. Excellent. Okay. Just making sure we're all set. Good morning, everybody. Thanks for being here. I'm going to share my screen real quick. Okay. Doing the classic. Can y'all hear me okay? Just want to make sure audio's feeling good across the board. Yeah. Okay, cool. Thanks for everybody in the chat. That's super helpful just for your feedback there. Really, really great. Okay, cool. Okay, yeah, everybody, thank you so much for being here. Good morning and welcome to the open guest lecture today with Ultraleap CTO and co-founder Tom Carter as part of our Hand Interactions Pro Event Series. I'm Joe Gabriel here, calling in from Seattle, Washington, as part of the XR Bootcamp team. And I'm just really grateful to have you here, have Tom and the Ultraleap folks here, and then everyone around the world. It was really cool to see all of, where you're calling in from at crazy different times of the day. So just very much thank you so much from the XR Bootcamp team. Quick introduction before we get started in the open guest lecture. I want to introduce a little bit about what we're doing with the Hand Interactions Pro Event Series for you, the developers, for the folks that are nearest and dearest to our hearts and that are deepest in the dungeons of advanced hand interaction development, right? So what we have coming up for all of these events, you're able to go to xrbootcamp.eventbrite.com to register for all of these, get all the event details, and to get the calendar invites to make sure to get that in your calendar. So what we have today is the deep dive with Tom. So we're going to be specifically talking about the business and future of hand interaction technology. And what's really great, I have a little fun story about Tom. So 2016, 2017, I was working at The Void, based in Utah, a location-based entertainment VR company, right? And we had this young, impressive team called Ultra Haptics that was coming in for a demo, and I got to host this team, and it was really great. They brought a little demo kit with them, a little sensor array. It was like this big, maybe this high, and they plugged it into a MacBook, and they said, "Okay, this is ultrasound technology, and you're gonna feel it." And I didn't really know what they meant by like ultrasound technology in that you're gonna feel it. All I knew is that you used ultrasound for seeing babies before they were born. Okay, so let's see what this is going to do. They turn on this demo, and all of a sudden I feel these invisible little bubbles rising up and popping against my hand. And this was mind-blowing. They had a little visual on the laptop where you could see the bubbles coming up. That helped a little bit with the conceptualization. And then also able to pass my hand through an invisible waterfall. And it was just mind-blowing to see, what Ultra Haptics at the time was able to do with this piece of technology for immersive experiences. And it's been really, really cool seeing the Ultra Haptics team evolve from then to what Ultraleap is now, and seeing Tom and his team continue to grow and be able to be such an awesome kind of industry player on the software and hardware side, as well as immersive content and more practical applications for some of this technology. So really excited to have Tom here with us today. This next Thursday, we have the rest of the Ultraleap squad meeting with us and on a follow-up open lecture. Chris, Hannah, and John will be meeting with us more for like a technical deep dive, specific industry use cases. So developers that are here today, please come check out again next Thursday for part 2 for a little more of that technical deep dive that you will be interested in. This Saturday, if there's only 2 things you walk away with today, the first thing is take all of those nuggets of information from Tom that he'll be giving out. And then number 2 is that this upcoming workshop this Saturday is a killer opportunity for all you hand interaction and hand input developers. It is the state-of-the-art hand tracking and interaction design workshop. The lead instructors will be Roger Kung and Dennis Kuhner. These are the co-founders of Holonautic and creators behind the Hand Physics Lab. Specifically in this workshop, you'll be going through interaction design, hand tracking, physics, locomotion, neuroscience, kinematics. And really this workshop's designed to help save you, the developers, hundreds of hours of what you would normally spend prototyping time, right? There's going to be a bring your own project section. So if you have a client-based project or a personal project that's using hand tracking or hand interactions of any kind, you can bring this during the segment and share it with Dennis and Roger, get kind of professional feedback, insights. They can help you with any troubleshooting, or if you're just not sure what to do or just looking for an expert level set of eyes to come look at your project and make sure that it's meeting the needs. This is the time to bring that project. You're going to learn things about how the human brain perceives reality, proprioception, developing a spatial computing mindset, very different from just other 2D development aspects, or even 3D games. Just spatial computing and immersive design. What does that look like? Kinematics and physics-based interactions, essential interface design principles across different product stages. What's that look like for your project? And then helpful design perspectives to build a fully functional and responsive interface. So that's what you can expect from this workshop this upcoming Saturday. You can get all the details at xrbootcamp.eventbrite.com. And for everyone on the call today, you can get your 20% discount code. We wanted to share with you, xrbootcamp20. But you got to take action on that here pretty quick. It's only valid till 4 p.m. Eastern today. So want to get that across your board as a super important opportunity. And last but not least, XR Bootcamp, we're launching our Advanced Hand Tracking and Interaction Design Masterclass. This is a advanced professional development training course, 8 weeks long, really just an awesome deep dive, again, with Roger and Dennis, who will be teaching this Saturday's workshop. They will be the lead instructors across this 8-week period where you and your team members will be really diving deep into creating amazing hand tracking and interaction design prototypes. And XR Bootcamp will also be including a Quest 2 as part of your learning resources. And so just real quick reminder, all the details that you just heard are at xrbootcamp.eventbrite.com. We want all your questions in the chat. Please hang around and just feel free to ask us anything. Let us know what you'd like to learn from Tom, and we'll be sure to share any of that. Again, grateful to have all of you and ready to turn the time over now to Tom with Ultraleap. And thanks everybody for being here today.
Hi everyone, this is Ferhan from XR Bootcamp. I would like to also, as Joe mentioned, I would like to introduce Tom. So we will have some kind of like a fireside chat. So the questions will actually flood today. Make sure that we ask everything in our mind in terms of Ultraleap's strategy and what is the hand tracking future looks like for Ultraleap and for the industry. So hi, Tom. I'd like to thank to you on behalf of the audience. We have today over 100 people watching us and VRARA, with the support of VRARA and our bootcamp, hand tracking bootcamp. And I'd like to ask to you, how are you? How is everything on your side?
Yeah, hi everybody, and thanks for having me. Yeah, things are good on this side, and I'm really looking forward to the event.
Perfect, perfect. So I would like to use this opportunity maybe for 20 to 25 minutes. We will discuss for several topics, but after that, I would like to open the floor and the stage to everyone attending to us, to our event, and make sure that they are actually asking the questions to you directly. So we can even possible that we can even bring the people directly talk with us with a video and audio. This is also possible in addition to chat questions. So there is a Q&A section for those who are attending that you can start throwing your questions. I will be looking at this. On the other side, you can also raise hand if you like to really be part of the discussion. I will actually invite our trainers and maybe some of our alumni to the discussion. So I hope that everyone will enjoy today. So without further ado, let's start with the recent announcements. It was quite exciting whenever we hear. It was all of a sudden, we know Qualcomm, we know Ultraleap, We know Ultrahaptics and Leap Motion, and we know how you much contributed for the last 4 or 5 years to the industry. But this was actually one of the major moves that we have seen from 2 big industry players. Can you explain to us what does the Qualcomm partnership means with Ultraleap?
Yeah, absolutely. It's a super exciting point for us to reach. What the partnership means is that Ultraleap's hand tracking technology will be pre-integrated and optimized on Qualcomm's XR2 chip. So the XR2 chip is what we expect will power the majority of the next generation of headsets, and our hand tracking technology will be there if any of the if the OEMs, the people creating the headsets, want to use it. So pre-integrated and optimized to run on the XR2. Really, I think this is super exciting because we have a lot of great developers building great content with our technology, which we really, really love. And I think this is going to be a real pivot point where that work suddenly has a much wider audience as the hand tracking starts to be a default that ships with consumer and enterprise headsets. So yeah, it's going to be super exciting.
Perfect. So a little bit more in detail. For example, in terms of when you look at the hardware manufacturers right now, headset manufacturers, what kind of accessibility and affordability opportunities waiting for us? Because all of the major players here working, all of us working for the adoption, right? The mass adoption that we are waiting for the maybe a few years, and we are hoping that it will happen soon, both on enterprise and consumer level. So what does it mean from the accessibility standpoint and affordability standpoint? How a hand tracking enabled headset can achieve mass adoption? Are you believing that this is something that can help, especially for non-tech savvy users, consumers, that can much better adapt VR, AR?
Yeah, absolutely. So I think a key aspect of building a headset is to understand its cost. And every feature that you add, the companies creating the headset will look at how much does it cost to add this feature, to add this functionality, what's the trade-off, and what's the value there. And what we're doing with the integration onto the XR2 is that our hand tracking is available on the standard reference design that Qualcomm provide. So if you are a manufacturer of a headset, you pick up the XR2, you can get the reference design from Qualcomm. It includes 2 cameras on the front of the headset and sort of linked into the chip and the system. And the cameras do both the 6-stop tracking, so the head tracking that tracks your movements as you move your head while looking into the room, and also the hand tracking. So realistically, if you're going to make a standalone headset that's going to have 6-stop tracking, there's no additional hardware cost to add hand tracking to these headsets now, which is a big change because previously, in a lot of cases, maybe you needed to add additional cameras, you need to add additional hardware or illumination. Every little bit of cost just adds that hurdle of will they add it or will they not? So I think that's really changed the barrier, and you'll see much higher adoption of hand tracking in the next generation of headsets. And then I think kind of more than that, if I genuinely believe that in order for XR to scale and to get that mass adoption that we're all looking for, it's got to be really simple to use. It's got to be really low friction. It's kind of the phrase that I've had since way before starting the company during my PhD is low friction. So it's got to be easy to dip in and out of the experience. It's got to be simple for people to just walk up and use. And putting the headset on is one thing. Having to have 2 other controllers that you've got to charge and pair and have with you increases that friction. So I think this increased adoption of having hand tracking available on the headsets will help with the acceleration and adoption of XR, because you start getting products that are just way easier to use, way easier for the consumer to just slip them on the head and dive straight into the experience. And part of that I was really excited to see. I think Hiram, one of the director of product management at Qualcomm, the way he describes it is hand tracking is now table stakes for VR headsets. So if you're making a headset, if you just want to be at the table, you've got to have hand tracking now. So I think that's a big shift.
Perfect. So when we look at the coordination between the manufacturers, of course, there needs to be a coordination on the headset manufacturer side and your support to them with the help of Qualcomm. And on the other side, there is, of course, like the software part of it that probably here we have lots of developers today. So they may want to see, it might be a great opportunity for them to deploy their hand tracking enabled experiences or apps in multiple platforms, right? So when you look at from this perspective, maybe considering OpenXR, will it be easier to deploy hand tracking to different devices? So maybe you can give some insights to us before, because it will definitely increase the encouragement or the motivation of developers.
Yeah, absolutely. So I think it's one thing to say Ultraleap's hand tracking will be on a much wider range of devices and headsets by default. That in itself makes it easier to build content and have it work on a large range of devices. So that's exciting, but more than that, also, as you mentioned there, OpenXR is a big factor here. I think so OpenXR is the open standard for accessing VR, AR platforms and devices. And I think getting to OpenXR v 1.0, which happened very recently, is a massive tipping point, because you always have that chicken and egg situation of people will buy the hardware when there's the content, and people will make the content when people are buying the hardware. So breaking that cycle is key to the success of any new technology industry that has this sort of like hardware software pairing. And I think what's better for the whole industry is that we don't see silos or ecosystems building up, but these kind of open standards that allow developers and creators to build content that will run on any device, any platform. So and I think there have been silos up till now, but that's not necessarily been because the different companies don't want to play together. It's just that there hasn't been this standard, this sort of forum to bring everybody together. So now OpenXR exists. We're part of it. We support it. We've released a beta version of our hand tracking that supports OpenXR. So then if you build any application that supports OpenXR, it will run on any headset that supports OpenXR. So that's really exciting as well.
Yeah, it's very exciting and good news for us. I really believe that. Think of every headset has its own dynamics and different limits. Making it in a much more standard platform will be a really best for the developers, so they can reach more wider audience. So in terms of your new device that you announced, maybe we can go a little bit further to that. Of course, we know the previous device and hardware from Leap Motion, Ultrahaptics. What should we expect from this device? Because I know at least like a few people just received their device, but we haven't tried yet. None of us tried yet. So what should we expect from this device? And when you look at the software side, how you are merging the, let's say, the knowledge and research that you have done on Leap Motion and Ultrahaptics in one device. I would like to understand better, because I think the merge of Leap Motion and Ultrahaptics is playing an important role. Maybe it is the first baby from this merge. We can say that, right?
Yes, it's the first product launch, I guess, sort of hardware product launch we've done since the merge. That's true. The product I think you're talking about is our new camera module that we've launched. So this is actually purely for the hand tracking. It's not quite kind of like a haptics tracking combo yet, like our haptics development kits are. So this has been a really interesting one, launching this camera module, because it is it is in many ways the next generation camera hardware to the Leap motion controller that many people bought and created a lot of amazing stuff on. The big difference between the Leap motion controller and the new camera module that we've launched is the new one is really targeted for integration. So it's designed for integration into headsets. So it's not kind of like a consumer finished product that's CE certified and kind of like water resistant and these kind of things. It's it is an evaluation kit. It is somewhat delicate compared to the metal edge device that you can throw around. But we wanted to make it available because we know a lot of people are going to build really awesome experiences with it. So I'm not going to say we're not slightly nervous that people are going to grab it and roughhouse it a little bit, but that's what it is. So in terms of the actual difference for the camera and what we're bringing there, it has a much wider field of view. It can track hands over a longer distance. It's got a slimmer form factor. It uses less power consumption. And the whole thing is really designed to be easy to integrate into headsets. So I think it's already in Vario's headsets, VRgineers, Pimax, and then Dreamcraft's Twilight Saga installations and exhibition that they've got. And yeah, it's super exciting. The difference that those specs bring makes a big difference to the hand tracking. So range is nice, but also that field of view is kind of the key. So the Leap motion controller has field of view of 140 by 120. This bringing that up to 170 by 170, particularly for VR. What that means is when you have the device integrated into your headset or attached to the front, really kind of anywhere you put your hands, it's going to be able to track them. The range is longer than your arms. You can move your arms around in front of you and it's going to track your hands wherever they go. It's a really cool experience sitting down and putting your hands on your lap and still seeing them track while they're sort of sat on your knees while you're looking up and forwards. So, there are a few people who've got hold of them already, and I've seen some responses and feedback coming back on Twitter, which is super exciting. And I think it does have that wow effect when you combine our latest software and that module. We've seen one person chatted easily the best they've ever tried, and so yeah, we're excited to see that appear in more headsets and people get hold of it and see what they can build, see what they can create with that bigger field of view.
Perfect. So some of us have already Leap Motion. We also, as a VR First and XR Bootcamp, we distributed Leap Motion to many universities, to many hubs, developer hubs. So if we have Leap Motion, you still suggest us to get this new device?
I think it depends what you want to do. If you want something that's really robust and you can develop with it, and if you're going to put it in sort of installations in art galleries or museums, a lot of people create amazing sort of artistic immersive experiences, then I'd say go with the Leap motion controller. It's sort of designed to be a standalone module. If you are somebody who's looking at building a new headset or hacking some kind of new hardware product and you actually want to build our camera into that product, go get the SAR 170, the new module. It's actually sort of a key point. If you wanted to build a hardware product before, you couldn't buy a camera module because you couldn't buy a Leap motion controller without the case that was suitable for integration. And then if you just want to experiment with that bigger field of view and create new exciting experiences, then yeah, go ahead, grab it and give it a whirl.
Perfect. There's one question regarding. I mean, I will go back to the questions. By the way, please continue submitting your questions. I'm asking to all the audience here, but please submit through Q&A button, not directly from the chat, because it will be easier for us to make sure that every question being answered or taken care of. So one question, Tom, about accessibility. Since we are already talking, I want to also want to mention about the use cases, but let's start from the accessibility use case. what are the things that you have seen so far, ultra haptics, leap motion, and this new device? What kind of especially accessibility use case that you have seen so far, which is really actually helping us that we cannot enable in a mobile phone or in any other medium?
Yeah, really interesting question. So probably one of the coolest applications that I've seen that just kind of make you happy is there's a company called Vivid Vision who's created this this VR experience. It has our hand tracking in it, and it's essentially a game which trains you to improve the condition of having a lazy eye. So it gives you two different images, one to each eye, and it changes the intensity or the brightness of those images or the clarity, and then gets you to play this game and helps train your body and your brain to use both eyes equally and sort of strengthen up the weaker one. So that always resonated with me because I think it's really cool to see these kind of applications that, like you say, yeah, you couldn't do that with a smartphone or anything else, and it's not just a cool, exciting game. It's it's generally making somebody's life better and helping them out. So those are really exciting. Outside of that, just sort of other types of applications, we see a lot for training and simulation, which is probably something that's not so visible. It's not so doesn't really get the sort of the clicks on the articles, but it's kind of really what Vario they create high-end headsets targeted at training and simulation. They have our hand tracking in, and they're used in all sorts of applications, including like the automotive design process. It's actually used in the creation of new cars, new vehicles. And the key with hand tracking there really is if you are training or learning to perform some kind of function, then rather than clicking a button in a general direction, you're actually starting to build that muscle memory. You're actually flicking the switch or pressing the button rather than just kind of waving a controller in the right area. And also something I didn't really consider at the beginning is a lot of sort of training centers, they have pretty high throughput. They need to get a lot of people in and out, and just having a tethered headset that you pull down and put on your head, no controllers to tether, charge, lose, sort of end up mixed up, just makes a massive difference on throughput and how fast you can put people through. Yeah, there's also entertainment applications which I think are more visible. Of course, the Void has our hand tracking and all of their exhibits, and those are really cool. That's sort of really for making you feel part of the experience, and I think really hand tracking can add a lot to that sort of social interaction. If you've got multiple people in an experience, avatars are great. Being able to actually have your hands and just the little hand signals that you do, we're so trained and kind of evolved as humans to pick up on these little details, the sort of little summons or little hand signals to make people pay attention or such like as they're communicating are really important. So yeah, those are great. And then one actually I'd probably mention it's outside of VR. So if I can just jump out of VR for a second, something that's happened or really taken off recently, which I'm really excited about, is making public touchscreens touchless. So naturally, we're all doing this via Zoom, largely because we're in the middle of a pandemic and there's a virus spreading around. And we're doing a lot of work to take public touchscreens, the things in transit terminals for buying your tickets, in immigration for processing in fast food restaurants for ordering your food. Those screens are a massive like transfer location for pathogens. Everybody's touching them and they never get cleaned. And we're taking those, adding a camera in our software, and now it becomes touchless and you can interact with it. Taking a lot of the controls and how to select options that we've learned from applications in the VR space and applying it to something that's not quite as immersive, not quite as exciting or fun, but hopefully providing people with a safe, hygienic way of interacting with these systems, which feels pretty good.
One thing that maybe I know that we have a special session next week on Thursday on that, but about this autonomous vehicle use case, maybe you can a little bit mention about that and any other enterprise application that stand out, because we know that, especially in our master classes, we see that there's a huge interest from enterprise as well as game industry. So happy to hear a few more use cases maybe from there.
Yeah, absolutely. So we do a lot of work with the automotive industry, and I phrase that into two parts. There's what we call the front of the car and the back of the car. So the front of the car is kind of vehicles today where a human is driving them, and the main focus there is enabling you to control the infotainment system of the car, change the climate control, change your music, answer a phone call without having to take your eyes off the road. So you can hold your hands out. The real key there is we can track what your hands are doing, and we can provide that tactile feedback, that haptics through the air directly onto your hands. So the effect of that is you don't have to find the controls can find your hands. You can press them, you can feel them. And the results are that I think we get about 20% reduction in driver mental load, and they make less glances away from the road. They spend less time with their eyes off the road. So it's improving driver safety. That's the key, that you can track the hand and feel it. And then the back of the vehicle looks slightly further into the future. We're really looking at autonomous vehicles. So once you don't own your own car, likely you sort of continue the Uber model, where if you want to go anywhere, you press a button, an autonomous vehicle turns up, you jump in it, and then it takes you to where you want to go. How are you going to interact with the vehicle while you're in there? And there's sort of a combo of factors there. One actually goes back to the hygiene factor again. If that vehicle's taking a few 1,000 people or so on journeys that week, do you really want to be touching all the touch screens and pressing all the buttons? Probably not. So having a touchless interface that you can still feel is really important. But then also there's what are the experiences going to be in the vehicle? I'm afraid the way the model's going to work is that the companies that operate the fleets will compete on price, which means your rides will be as cheap as possible. But then they will look to monetize people once they're in the vehicle. So how can you, whether you can enable people to do their shopping there, sort of tie-ins with companies that will deliver things for you or such like. And the example you mentioned there, this what we call backseat driver demonstrator, was a VR experience that we created, which transports you into one of these autonomous vehicles and enables you to do shopping, to browse social media, browse the web, watch videos, and of course, because it's all VR or soon to be AR, you can just make the screens as big as you want, position them wherever you want. We have really cool like interaction mechanisms for grabbing interactive elements that you're going to work on and throwing them into the space in front of you, and then a cool sort of wellness or well-being experience as well. So can you use the haptics and the hand tracking to relax people and to calm them down and make it a pleasant environment to be when you're stuck in traffic. So yeah, it was a really cool experience. It's got a lot of great feedback, and it kind of ties in a lot of what we're seeing behind the scenes in the automotive section, some of the work that we're doing there in a way we can show off publicly. Yeah, one of our I think actually Hannah's going to talk about that next week, and a lot of the user testing and how they built that into an experience that people really enjoy.
Perfect, perfect. We have almost 12 questions right now, so I will really leave the time for these questions because there are very interesting questions, a little bit challenging questions, I should warn you beforehand. So at least in terms of your positioning in the industry. One last thing that I would like to ask, especially for enterprise again, have you measured the ROI, like an enterprise application with controllers or another input method versus hand tracking? Do you have, I think I remember that I have read a few blog posts about that, but can you share with us like what kind of ROI that we should expect in terms of development costs or in terms of even the user experience and even like the impact of the experience for the use case?
Yeah, we've done it for a bunch of different applications, particularly for, we had a great study commissioned for automotive comparing the ROI of midair hand interactions versus touchscreens and the differential that makes on your experience as a driver. And we've done it in some entertainment settings as well. I can't say that we have public figures anyway that we've shared for the comparison between controllers and hand tracking for enterprise VR applications. Partially because they're so varied, like that's a challenging thing to measure, I think. But yeah, we haven't published anything yet on that.
Okay. Okay, then let's start the Q&A session. What I will do is our team will actually now add our instructors, mentors, and alumni of the hand tracking. So we will have a much more like a forum type discussion as much as we can. So our team is adding that right now, our alumni. In the meantime, I will start actually asking the questions. So there's one boring licensing question they mentioned. Revate is saying, so for developer licensing, I noticed that public demonstration is unchecked. Does this only apply for public displays of the hardware, or is any software developer work of limits to show as well?
You're diving into the legal world here. From the top of my head, I'm pretty sure that we have retained both the haptics and for hand tracking the ability to for developers to create something and to demonstrate it. So I think if you're doing it for a non-commercial use case, you're not sort of building a product, and you are trying to show off something that you've created, I don't think that we stop that. I think there are certain thresholds where if you're building a product, then yeah, you just come and talk to us. If that doesn't make sense from looking at the website, then drop me a message on Twitter and I'll make sure that's sorted out, or drop an email to our support. Yeah, we don't stop people showing off cool things that they're making or prototyping.
Okay, perfect. So let's go to very quickly to the other question. How do we get access to the reference design for prototyping and MVP?
So just on our website, if you go to ultraleap.com, click on tracking, and then there's the, I assume this is the reference design for the camera that's there. If you're talking about the reference design for the Qualcomm XR2, then I don't actually know the answer to that. I think you'd have to go to Qualcomm's website and find the XR2 and look through there. I have to say they just kind of send us them in the post. So I don't know how you get a reference design from Qualcomm.
Perfect. So very quickly, another question. Can I design and manufacture a real-time product using hand tracking Ultraleap technology? How can we give GDT for precision, GDNT for precision mating parts?
So real-time product using hand tracking. So I guess this is meaning that they're using hand tracking to provide some input and then something's being manufactured as we do it, I guess.
Or I don't know, maybe real-time 3D as well, but since it says product, maybe whoever asked this question, happy to accept this person and directly ask to us, because we have, let's skip this for now. And maybe we can, since we have already a few members here from the hand tracking masterclass, mentors and alumni and instructors. So anyone who would like to ask directly to Tom, you can raise your hand, and also you can just unmute yourself. I know that Ian, you had one question.
Hi, yes, I do have a question. So the new Ultraleap sensor has a much smaller form factor, and that's to focus on better integrations with virtual reality headsets in this next coming generation. Do you have any thoughts or predictions about possible future integrations with augmented reality devices? And I'm very curious on that, because especially as in terms of augmented reality devices are probably going to be a lot smaller. Like the ones that are going to reach mass adoption are probably not going to look like HoloLens sized devices. They'll probably be a lot closer to eyeglasses. So do you have any thoughts as the form factor is getting smaller for virtual reality? What do you see in ways of future integrations with augmented reality devices?
Yeah, I think that's a really great question, Ian. I think you hit the nail on the head there. That I think this this new module will be installed into a lot of VR headsets. You're not going to see it in a huge number of AR headsets because AR just has more focus on size, cost, power consumption. As you mentioned, the key for us there really, we'll continue to have sort of like lead the like design of camera hardware for hand tracking to create like what is the best experience for hand tracking. But what we've done with on the software side is that our next generation of hand tracking software is not tied purely to our camera hardware. So in the past, if you got V1, V2, V3, V4 of our hand tracking software, the only thing it would work on is a Leap Motion controller, and now our new SR170 camera module as well. But the new version of the hand tracking software can run on different types of camera hardware created by third parties as well. Not every type of camera out there, but more and more over time. That's kind of how we built it, how we've designed it. In terms of the software, we can get it really, really low onto low compute platforms and low power consumption. So the move for AR really will be that, again, the same cameras that are integrated onto the headsets that are used for the 6-stop tracking, for the head tracking, we'll get the hand tracking running on those same cameras. So that's the plan.
Thank you.
Thank you, Ian. James Powderly, you had one question, as far as I remember.
Yeah, hi, Tom. I was just, yeah, thanks for speaking today. I was just asking a little bit along the lines of Ian's question. Just your thoughts on what's the necessary field of view size to have a good hand tracking experience, specifically in that AR space. Is 170 by 170, is that kind of beyond what you'd recommend? How does the field of view size relate to that? What's a good kind of feeling hand interaction experience in terms of the display field of view too?
Yeah, I think that's a great question. And the display field of view for me is the key there. Having a field of view for hand tracking that is smaller than the field of view for the display, I think is a bad experience. It's really jarring to be in a VR and AR experience and be able to use your hands in some places that you can see and not in others. So certainly we'd like it to be at least the same size as the visual field of view, but actually a lot better if the hand tracking has maybe sort of like 5 to 10 degrees extra field of view each side. And the main reason for that is that means if your hands are coming into the scene from outside, the system picks up the hands and starts tracking them and sees what they're doing before they come into the visible field. It also means that if you're holding something and you kind of look away, there's more chance that even though your hand disappears out of the visual field of view, whatever you're doing is going to continue happening there. So yeah, generally I would say get the visible field of view and then add ideally something like 10 degrees to that.
Perfect. It's very nice to see our hand tracking first cohort alumni joining us today. So let's continue. Actually, we have, of course, a little bit priority to the masterclass students because we want to make sure that they are continuing their learning journey with these open lectures. So one of our mentors, Mark Stillman, I think, Mark, you had one question. Would you like to ask or?
Yeah. Hi, can you hear me?
Yes.
Hey, I just wanted to follow up with what Ian asked about kind of fitting the hand tracking tech into smaller form factors like AR glasses. I'm wondering if you think it's possible to fit like the haptics part, the ultrasound haptics part as well into like a standalone HMD, and if so, like what are the primary challenges? Because I imagine there's might be, you know, kind of power consumption issues, and yeah, I'm just curious about that.
Yeah, that's a really great question. Thanks, Mark. So I think the answer to that at the moment is it's possible, but I'm not yet sure it's a good idea. So we have smaller form factor hardware coming through, and we have loads of really interesting and funky experiments we've done in our office. I'll post the pictures publicly sometimes of kind of like headsets with arrays strapped to the front of them and people testing things out. The first thing I think before we end up like really diving into the logistics with the hardware and the power consumption is just how you're going to interact. So if you have the haptics embedded into the headset, then the force of the feedback is going to be projected forwards. There are some really cool interactions you can do there, sort of holding your hand up and having a sort of a display on your hand, which you can then interact with and feel things on. But generally, it means it's going in the wrong direction for the interactions you're doing with the world around you. And even if you just think of getting to menu items, and if you want to press a button and feel it, it's going to feel weird to kind of press it into your face in order to get the haptic response. So we've explored and experimented in our team at building these kind of experiences all the time. We've looked at multi-user use cases where you have people with the haptics integrated into their headsets that project the feedback to each other, and all of these kind of crazy experiences. But at the moment, the best like setup over the, you know, certainly 2020 and 2021 is going to be to have the hand tracking in the headset and then the haptics. If it's like a location-based entertainment thing where you go around and experience, they're embedded into the walls there, so you kind of go up and do whatever activity you're going to do inside that experience, and the haptics is there. Or if you're doing some kind of enterprise application, something like design where you're sat at a desk, then you have a module actually on the desk in front of you. But yeah, cool question. Thanks.
Just quickly adding on to that, do you think that we're going to see like significant improvements in the accessibility, like namely the price point for the ultrasound haptics?
Yes, definitely. There'll be quite a big shift there, but and we're not a million miles away from it, but I'm not going to put a timeline right now. So yeah, keep a watch out, and it's coming.
Perfect. Thank you, Mark, for these nice questions. We have to be quick. We have 10 more questions. And Richard, you had one question. Richard is also our mentor from the first hand tracking masterclass. He is the master of gloves as well. So very quickly, Richard, nice to see you.
Yeah, hi, Tom. Hi, Farhan. So specifically, I'm interested, you guys had a partnership with Pimax, and I ordered the hand tracking module about almost 2 years ago now and still waiting for it. They said that it should be coming next month. So I just wanted to hear your input on what it's like working with Pimax and what to expect when I finally get that, because they've been saying that it's going to be wider field of view, but sounds like it already has wide field of view. So I'm guessing it's probably going to be the same as everything else, 170 degrees. The other thing is the main reason I bought the Pimax with the hand tracking module is I'm interested. I've been working with VR gloves for the past few years for this company, Noitom. They have the High Five VR gloves, and those are IMU based gloves. So what's nice about it is it works anywhere. It doesn't have to be in the field of view of any camera or anything, just the Vive base stations to see the Vive trackers. So pretty much you have, you can have your hands behind you, in front of you, wherever. So I think that's nice, but the problem is since it's IMU based, you don't actually have the optical tracking that something like Ultra Haptics would give you. So I'm interested in trying to combine like the Ultra Haptics with the VR gloves. So I'm wondering if there's been any thought with you guys with doing something like that, and if there's any interest.
Yeah, really good question. So I'm not really going to comment too much on Pimax and working relationship there, primarily just because I've not been there for all of that. So apologies that you've had to wait so long to get the module from them, but the merger only happened last year, so I've not really been sort of there from the beginning of that, so I can't really comment on the full story. But what I can tell you is the module you're going to receive has this SIR 170, it's our camera module embedded in it. So it is going to give you the full 170 by 170 degree field of view. And I think that'll match up and be a great experience with the Pimax headset and the wide visual field of view that they have there. On the combination with gloves, I think there's always applications to tie two great technologies together when there's like a specific benefit of getting those two features. Like you say, there are things that our hand tracking can't do, and there are things that the arm gloves can't do. So where there are specific applications that the combination of those two features is really, really important, then yeah, absolutely combine them and make use of it. I think it's one of the exciting things about the whole VR space is that you see both the mainstream consumer aspects, where I was talking earlier about, I think that really is low friction. Even getting somebody to put a headset on is a pretty sizable amount of friction there. But then there are so many applications where like a specific setup or a specific use case gives you so many benefits. So yeah, we see a number of applications where you combine our technology with the sorts of tracking or other sorts of other sorts of sensory detection systems and create something pretty special.
Yeah, because I'm thinking like with the movie Ready Player One, you see them using VR gloves. So thinking, you know, in the future when we want the full immersion and we want the most accurate hand tracking, then maybe some kind of combination might be good. So I was just wondering if you guys have been thinking about that, or if you're more focused on kind of more of the present with getting VR in everyone's hands.
Yeah, I think our view of the world, sort of as it evolves over time, is that the best hand tracking will be optical. Like we'll slowly be able to build out our functionality to be able to do better hand tracking than you can do with sort of sensors that you put on your hand. And also, naturally, a lot of the Ready Player One reason they wear gloves is to get the haptics. And same as we get the Minority Report comparison trotted out a lot. And the thing I always say is, you know, Tom Cruise wore gloves. He's got those little gloves on, whereas our focus, both with the hand tracking and the haptics, is being able to enable you to have these experiences without having to put anything on your body. And that's kind of the one of the key sort of visions that we have in the company is this: like, don't wear anything, don't touch anything, but you can still interact and feel what you're doing.
Yep.
Great.
Thank you.
Thank you, Richard. So we have really limited time. Maybe one more question. I would like to, first of all, invite everyone to next week, because next week we will go a little bit deep dive, like technically and use case based. So you will have, we are now actually capturing all these questions and we will make sure that it's being answered. The other thing is we have, as we are always doing after guest lectures, we have Discord networking event. So in our Discord channel, our team is sharing the Discord invite with you. So for those who would like to continue the discussion, and 1 hour, for those who thinks that 1 hour is not enough, we will continue there to discuss. We have one final question, which is, I also believe that this is something that everyone is curious about. What is the key advantage to other hand tracking technologies like Oculus hand tracking? So I would like to also invite actually our trainers who are having already an hand tracking background, especially they have SideQuest hand tracking, hand physics lab, Dennis and Roger, the trainers of our hand tracking masterclass. Maybe they may want to add comment, or they may add a few different perspective to this question. So Tom, what do you think, like what is the key advantage, or what are the different perspectives that you as Ultraleap and Oculus hand tracking is following right now?
Yeah, I mean, I can't speak for the team at Oculus as to what their perspective of development is. We've taken two slightly different approaches to how we build hand tracking, and for us, I think where I believe our hand tracking gives a better experience is some of the key aspects of the experience of using hand tracking that we focus on. So one big example is initialization of hands. So when you bring your hand into the scene, how fast does the system recognize that there are hands there and start tracking? That's super, super, super important because particularly when you go towards consumer products, if you're putting it on people who aren't techie themselves and they hold their hands up and it doesn't work, they can't see the hands, and you have to sort of, that sort of thing we've learned over years with earlier implementations of hand tracking, where you kind of have to give your hand a bit of a shake to get it to detect. Those things are bad. So we focus on that. So initialization, and then we do a lot for robustness, particularly for multi-hand interactions. So being able to actually touch your hands together, kind of do this kind of stuff, and have one hand go over the other hand, and so the camera has one of the hands occluded. We can keep tracking in those scenarios, and those are the things. So yeah, I'd say top of the list in my view anyway is making sure when your hands are in the scene they're being tracked, whether that's just when they appear and then making sure they don't disappear when you're doing various interactions with two hands together or one occluding the other. And latency there as well, I think is key. We worked very hard on getting very, very low latency hand tracking, so you don't just even like tiny amounts. Certainly you go above 20 milliseconds and you really notice the you notice the latency. You start perceiving your hands. I think if you looked at the long-term trajectory of hand tracking, where does it need to get to? Like, what's going to be a great hand tracking user experience in the future? Because it's novel now, you still get that sort of there's that coolness and that excitement of being able to use your hands in virtual reality. We'll know that we've succeeded when nobody mentions using their hands. Like, your hands are just, you ignore them. Same as touchscreens. As soon as they went to that sort of high refresh rate, nobody talks about using a touchscreen. It's just the thing that's always there. So yeah.
Perfect. So actually, Jim asked this question, like, is it under 20 milliseconds? Your last
hand tracking. Yes, yeah. So it actually gets down lower than that. The latency depends slightly on some environmental factors, like how bright it is, and also how fast your hand's moving. But generally, yeah, it's substantially lower than 20 milliseconds, often down sort of around 10 or less.
Perfect. Roger, you are mostly, of course, we know that you are mostly developing games and apps at Quest, but I know that you already have different experience with different hand tracking technologies. So do you have any question or comment to add?
Yeah, like one of the main pain points. So first of all, like the increased field of view is definitely a big welcome for us, like because that's one of the main pain points. But the second area where we have difficulties with the Quest tracking is when you go a little bit further away from your body. And often when you want to reach something, then you lose tracking. It's just so frustrating because with the controller, it works very nice, right? And the field of view is one thing, but also the distance, not just the degrees up and down, left, right, but also the distance, how far you can track something and still be able to manipulate objects. And I was wondering if there is also a big improvement compared to, the current standard or what it was before.
Yeah, so the distance at which you can track is primarily dictated by the hardware. So it's how high resolution are the cameras and kind of what's the field of view of the camera. So if you think about it, you're taking the resolution of the camera and spreading it around over the field of view. And ultimately you need a certain number of pixels that make up the hand in order to be able to track it. So with our hardware, with the new camera module and the sort of the unit that we're integrating into, lots of companies are integrating into their headsets, that has a range of up to 1 meter that it can track. And one of the main reasons that it was set at 1 meter is that so far we haven't found anybody who has arms that are longer than a meter. So the idea is that you can hold your arms out as far as you can and move them around, and it will. So, yeah.
Okay, that is a very exciting news. And what the Air 2 like will come out with, is that what will be also in the standalone headsets? Like, are those comparable? What will be shipped like in the basically from Qualcomm chip? Is that basically the same quality we can expect?
Yeah, so the Qualcomm reference design doesn't use our camera hardware. It's sort of an example, one of the first maneuvers of our software being deployed on other camera hardware, which is really exciting. But the specs of the camera hardware are pretty similar. They're not exactly the same, but in terms of field of view and range that you can track at, it should be comparable. Yeah.
That's very exciting. And one question, like Oculus has a very limited kind of API, to get data from the hand tracking, like gesture recognition or anything like that. It's basically just a pinch which you have on certain fingers. Will that standard design also come with a SDK which has maybe a little bit more integrated, or will it be basically the raw data? Because most of the applications will basically just use the raw data and then build our frameworks on top. And I was wondering if there will be more coming to make the interaction design a little bit more convenient for the majority of developers.
Yeah, so any developers building experiences without hand tracking, whether that's just with a Leap motion controller right through to headsets that feature our hand tracking technology, you can use our SDK, you can use our APIs, and that's all there. You can use our tools like the interaction engine, which builds up all of these ways of doing really good grab interactions and interacting with objects at a distance, which good segue. John's going to be talking a bunch about the sort of insides of how that's built next week. And the other thing I'd also mention is OpenXR. So obviously we're part of OpenXR. So the idea is that the OpenXR API will evolve and get more full featured over time. And then if you build any kind of application using the OpenXR API, it can run on Facebook's hand tracking, it can run on our hand tracking, it can run on sort of any headset. So yeah.
Yeah, we hope that is coming soon.
Perfect. Really, we are waiting for this, the fruit of this cooperation with Qualcomm in other headsets, so we can add that directly to our masterclass. This is what we are waiting for. So we will be probably one of the first who will start announcing the hand tracking and hand interactions in any headset you want. Most of them are already powered by Qualcomm chipsets, so it will be great for everyone. Dennis, you have one question before we close?
Yes, sorry. Hi, Tom. So I had one main question is, what is your take, or how do you handle the tracking confidence when the finger are looking away from the camera? For example, if the wrist is in front of the finger, is there a way that you can use the arm information to prevent that the hand loses tracking? Because I know that's a big issue on the Oculus tracking. As soon as the finger are not visible, it basically also loses the hand position completely. That was one of the main issue I had to deal with for hand physics lab, that it doesn't like completely go glitchy. So is there a way that you can really use the arm information and maybe more information from the body to not lose the position of the hand? Do you have maybe a system that uses that for Leap motion hand tracking?
Yeah, absolutely. That's exactly what we do. So we use every bit of the hand, the arm, the body that we can see to guess or establish what positions the hands and the fingers will be in. So if you can't see the fingers, if they're pointing away from the camera, you can usually see like the arm, the hand, and then there's usually some kind of little details of the fingers that are visible, and our hand tracking will use those little details to figure out where the fingers are pointed. That gets better with the next version of our hand tracking as well. So that's something I'm super excited for everybody to be able to get their hands on and play with in the not too distant future.
Okay, great. Are you also planning to add potentially full body tracking, as also Oculus is planning with their body API also to your SDK?
We don't have plans on releasing something like that at the moment. It's kind of like a maybe up on the wall, something we could do. Like we could start tracking things that are more than hands, but right now our focus is on doing a really great job of tracking hands and then getting that out there into headsets that are accessible that everybody can get hold of and build great content for. So that's the focus.
Okay, thanks.
Great. So we are a little bit out of time, and but the good news is next week, at least Tom, your team will be with us. So we will go deep dive into 3 different use cases and principles. I think you can also check for those who are interested. Please sign up from today, so it will be in your calendar. So I'm looking forward to the next week lecture. And we will continue. This is, as we mentioned, Hand Interactions Pro event series. So for the last already 1 week with Roger, Dennis, and with other speakers that we are trying to explore. There are many things to explore. So we will continue about that. Principles class, master class. And thank you, Tom, for being with us. And thank you, everyone, for these great questions. Don't worry, your questions is already being stored, and we keep it for the next week. So it will be answered. I will already share this with the Ultradeep team. So next week, we will make sure that we have an elaborate answer actually for your questions. And hoping to see you in the next week's event and principles class as well. And thank you everyone again, and have a very nice week. Bye.
Thanks, everybody. Thanks for your questions. Thanks for having me.
Thank you.
Thank you. Bye.
Bye. Thank
Thanks,
you.
Tom.
Discord
Aaron.
party. Bye.